A wonderful morning. Welcome back to Sonnet Institute of Technology. My name is Bruce Malauti, and I'm so glad to walk you through this demonstration. In this particular demonstration, we'd like to answer one of the common questions that has been asked. And the question goes like this. At what layer of the OSI model or the TCP IP stack is Icmp protocol? So there's been a lot of confusion among network engineers who are not sure whether Icmp is a layer 4 or layer 3. And in this particular demonstration, we are here to try to prove where Icmp protocol operates. So as a matter of fact, for those who know, we all know that Icmp operates at layer 3, and we know that Icmp has a protocol number of 1. And in this exercise, we like to approve or disapprove these facts. So for those who believe that Icmp operates at layer 4 and above, we would like to demonstrate and show them that Icmp only operates at a maximum of layer 3. It doesn't go beyond. So I will have 2 exercises in this demonstration. So the entire topology will have 3 devices. The first device is the Cisco router, which I will assign that IP address, and then I'll fill in the MAC address once I copy. And then the second device is a Linux host that will be assigned an IP of 10.10.10.2 on a /24, and the MAC address will follow. And then the third device is a Linux host number 2 that will have that IP address, and the MAC address will be filled in later. So I'll be using a built-in generic layer 2 switch so that I don't mess these MAC addresses. We'll be using these MAC addresses and these IPs when analyzing our captured packets. So in exercise 1, we'll be analyzing an application, or can I say a packet that has been generated by an application such as SSH, Telnet, FTP or HTTP, just to name a few. So I will particularly SSH from a Cisco router to a Linux host 1, and of course we'll capture the traffic using a protocol analyzer such as Wireshark. So once we capture the packet, from the analysis we expect to see packets that are utilizing the protocols from the bottom layer up to the application layer. So these protocols will include ARP, that is IP to MAC address translation. We will have IP, so which means we should be able to see source IP and destination IP. We will have a protocol number, we should be able to see that. We have TCP or UDP. We should be able to see port numbers as well, that is source port and destination port. Since we'll be using SSH, our destination port should be 22. So let me include that, TCP 22. Okay, and we should be able to see what kind of application has been used as well. So in exercise number 2, we'll be analyzing an Icmp packet such as ping. So in this demonstration, I will ping from Linux host 2 to a Cisco router, and I will send 5 ping requests. So I'll make sure that I'll be capturing the entire session. Once we capture the session, we will analyze the captured packet, and then we'll break it down and try to see as we did in exercise 1. And after that we'll come back here and then we conclude our analysis. As you can see, the conclusion states our results show that ICMP, such as ping, is a layer dash protocol. So we need to fill in this gap. Is it a layer 3 or a layer 4? So let's find out. So without wasting time, let's get to GNS3 topology. Here we are in GNS3. Let me create the topology. So I'll have a Cisco router over here, and I'll have a generic switch. I will then have 2 Linux hosts. Okay, and then let me wire these together. Okay, and I need to do basic configurations. So this guy will be on a 10.1 and this one will be on a .2. Okay, so this is the complete topology. As you can see, we are on the 24 subnet, that's 10.10.10.0 subnet, and the router will get an IP address of 1. The host 1 Linux host will get an IP address of .2, and the second host will get an IP address of 3. Okay, so let me switch on these devices. So I'll just click there, and the devices are booting. So I'll start by configuring the Cisco router R1. So I just have to double click to get to the console. So on the Cisco, I know that Ethernet 00 is connected, so I will start configuring. So that will be configuration terminal. Select the interface, that is Ethernet 00. Assign an IP of 10.10.10.1 on the 24 subnet. Then bring the interface up, and I can exit from there. So if I do show IP interface brief, I can see that my interface is a layer 3 IP, and it's up. But I need at this point of time I need its MAC address. So that will be show interface Ethernet 00. Okay, it's a lot of information, so let me trim down. So that will be show interface E00, grep include hardware. So here's my layer 2 address. BIA means band in address. So I'll copy that, come to my template and paste. So this is our MAC address for that Cisco router. So I'm done with the Cisco router. Exit, and let me go to host 1, which is a Linux host. So I can log in. To manipulate IP addresses in a Linux host, you must be root at most times or use the sudo command. So in my case, I like to be root. So that will be sudo password root. I like to change the password, the root password, because I don't know it. So that will be su root. Right, and clear the screen. So I will change the host name to host 1. Okay, as you can see, the host name has been changed. I will also check the IP address. So I've got Ethernet 0 and has no IP. So I would like to assign an IP. So that will be IP address at the device is Ethernet 0 and the IP address will be 10.10.10.2/24. Now if I do IP address show device Ethernet 0, you can see that I've got an IP address and I need to copy the layer 2 address. So copy that, that's our MAC address, get to our template and paste. Okay, and from here I can assign a user. So that will be add user Bruce, because I like to SSH, so I like to add the user Bruce. Okay, so now we have a user Bruce. We got a layer 3 IP address. We also copied the MAC address. So I'm done on this host, so I can close that. And on this host, we'll do the same. Change my root password because I don't know it. Okay, I made a typo, so I'll do it again. Okay, so I can su to root. Okay, and let me change the host name to host 2. Okay, so host name has been changed. I can check the IP address that is allocated at the moment. So that will be IP address, enter. So I have Ethernet 0 and has no IP address, so I can assign one. So that will be IP address add the device is Ethernet 0 and my IP address is a .3//24. So if I do IP address show device Ethernet 0, here's my IP address, and I would like to copy this. So bring my template and paste. Okay, so please take note of these IP addresses, and we'll be using them when analyzing the packets. So I can minimize that and I can close that. So coming back to our plan, everything has been set and this has been completed. Now we need to jump into exercise 1. So exercise 1 requires us to SSH from the Cisco router to the Linux host, which is host number 1, and at the same time we'll capture packet, the traffic or the session. So let's do that. Come to the link, right click and click capture. Okay, so here is Wireshark capturing in the background. So I'll minimize Wireshark and try. Okay, so once it's minimized, now I need to SSH from the Cisco router to this Linux host. So double click there to start the console. So I will SSH, specify the version, specify the login username, and specify the IP address of the host. Okay, so enter the password. Okay, as you can see, I'm logged in and I can do some basic Linux commands such as uname -a or ps-aux, or I can use the top command. Okay, so these are basic Linux commands and I'm logged in Linux. So as a matter of fact, I can quit by pressing Q and clear the screen, and I can exit this session. So session has been closed. So let me exit from here and then stop Wireshark. Okay, stop Wireshark. So let's scroll and see what we have here. So what we have here, I can filter my results. So I'll type in here app and then apply. So as you can see here, we have an app request. So 10.10.2 was requesting for app, and actually the router itself was requesting for the layer 2 address that belongs to 10.10.10.2. so let me minimize this. So this guy here, the 10.1, is trying to reach 10.2. Now this guy here needs a layer 2 address for that guy, so that's where app comes in. So this guy will send an app request, which is a broadcast, and then whoever has that IP address will respond. So that is what we see here in our app packet here. So if you read the message here, it says who has 10.2.2, please tell 10.1. So here's the layer 2, and you can see that the source MAC address, it's a 16:00. That's the source. And if you come back to our plan, this guy here, you see it's a Linux one, and we got the destination here. The destination, it's a 1.0.0. that is a Cisco router right here. Okay, so that is up. So let me clear this. Now let's go to SSH. So I can filter using SSH and then say apply. Now if you look at any packet that has SSH inside, you can see that we got layer 1, we've got layer 2. As you can see, we got the MAC addresses involved here. We got the source MAC, which is a 01:00. That's the Cisco router. And then we got a destination of 16:00. So if you look closely here, 01:00 is the Cisco router, and then 16:00 is the first Linux host. So that's layer 2. Layer 3, that's where we see source IP and destination IP. So the source IP is a .1, that's a Cisco route. Destination IP is a .2, that is a Linux host. And then on layer 4, we have a source port, so it's a random port number. And then destination port, as I said, SSH uses port 22, as you can see here. So if you look closely, as we predicted here, port 22. Okay, and coming to the upper layer, which is the application layer, we can see that we have SSH version 2. So if you scroll down, you can get to know more deeper things like the sessions, encryption, and all those stuff. But we are interested in looking at what layers does SSH operate. So as you can see that SSH operates in all layers of the OSI model or IP stack. So as you see that there is layer 1, layer 2, layer 3, where you find our logical IP addresses, layer 4, that's where you find TCP or UDP. In this case, we have TCP, that's Transmission Control Protocol. We also have port numbers. So we got our destination port and source port. Then we have our application. So I will close this window and stop this session. Okay, so the next thing I need to do now is to simulate Icmp. So I will ping from this host to that machine. So I will right click, then start. Okay, Wireshark running in the background, so I will minimize that. Now I will send a ping, 5 packets or 5 ping requests to the Cisco route. So what I will do, double click here, and I will say ping, send 5 packets and the IP address of the Cisco router. So that those are my 5 ping. So I'm done. Come back, bring Wireshark and stop. So let's analyze these packets, and we're interested in Icmp. So our source for this Icmp source was .3 and destination was a .1. So let me do this. This is our source .3 and destination is a .1. And if we look closely, our source MAC address should be this guy here, 3900, and our destination is a 0100. So let's get back to our Wireshark capture. So let's do app first. If you look at app, we have a source of let me do this. Okay, so here's a source. 3900 is requesting 3900 wants to know what's the MAC address to the .1 device. So if you look closely again, you can see that the target IP is a Cisco router here, right here, 10.10.10.1. So the Linux host is requesting what's the MAC address of that router. So you have a app reply, which the Cisco router replied saying its MAC address is ends with a 0:0. So let's get to the interesting part, Icmp. So if we count our packets, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now it's 10 because we sent 5 Icmp requests and then we received 5 Icmp replies. So if I filter more, furthermore, and this is what I have. Okay, so here are my ping requests which I sent, 5 of them, 1, 2, 3, 4, 5. And let's scroll, or let's analyze one of them. So if you take a look at one of them, you'll find that there is layer 1, there is layer 2. As you can see, we got our source and MAC addresses, and then we have layer 3. We have IP addresses, we have our source IP and destination IP. And if you look closely, we don't have layer 4. So we don't have UDP or TCP. We don't have application layer as well. And right here on layer 3, I'd like to show you something interesting. Let's look for the protocol number right here. Icmp uses protocol 1. So As we can see that Icmp works from layer 1, layer 2 and ends at layer 3. There's no layer 4 on this. We do not have source port, we do not have destination port. And to summarize this, we can conclude that Icmp operates at layer 3 like that. And looking at our packet, as you saw, the maximum you can get is layer 3. So to answer your question, Icmp operates at layer 3 of the OSI model, and Icmp is protocol number 1, as you can see right here. Protocol 1 is Icmp. I'd like to thank you for watching, and I hope this has been informative. Goodbye for now.